Hello, welcome to my YouTube channel. Um, Today we're going to start an interesting journey to talk about nuclear and particle physics that is studied in the university. And we're going to start with our very first lesson today, and it has to do with introduction. And in today's lesson, we're going to do the following. We're going to examine the relevance of nuclear and particle physics in our world today. We're going to talk about the origin of nuclear physics and the origin of particle physics and the different classification of particles today. And we're also going to talk about how particle physics is a little bit different from the study of nuclear physics. So moving forward, we'll start with the very first item on our lesson outline, that is the relevance of nuclear and particle physics in today's world. Students in the university who are taking nuclear and particle physics as a core course should understand that it's not just earning some credits, validating some course, or getting some certificate. No, 1,000 times no. Nuclear and particle physics happens to be one of those key branches of physics with concepts that are widely applied. Now, apart from the knowledge obtained by studying nuclear and particle physics, which of course help us to understand fundamental concepts of the material world in which we live in, the study of nuclear and particle physics is very relevant today, and its application extends to many fields. Let's take, for example, the medical field. Nuclear physics is used in radiation therapy in the treatment of cancer. Nuclear physics is used in medical imaging, which is a medical technique used to view internal body organs without surgery. Now, we are not going to go into the details of this application. The purpose of this lesson is to expose us to the relevance of nuclear and particle physics. It's just to give us an awareness so that we know why we are studying it. Energy production. Nuclear physics is also applied in generating energy using nuclear reactors by employing two processes by which energy can be released from the nucleus. That's fission and fusion. Fission reactors are already in existence, but fusion reactors are still under construction. And it is going to be one of the biggest breakthrough in the application of the concept of nuclear physics when it will be finally realized. Nuclear and particle physics has inspired research into fundamental building blocks of matter, which has led to the building up of accelerators and detectors technologies. Now, these technologies were initially built to investigate the fundamental components that make up matter, but now they are being used in other fields to advance knowledge in healthcare and aerospace. Another key area is material science. Now, material science is all about the study of the different materials that we have in the world, their properties, and how they can be mixed together and tailored to be used for particular purposes. Now, with these new technologies, it has made the investigation of the properties of materials possible, and such knowledge has led to the development of new materials with specific properties. And we will end with archaeology, radiocarbon dating, which is a technique that is used to determine the age of organic materials by measuring the activity or count rate of carbon-14 in them. These and many more are some of the applications of nuclear physics, and so it is a very important study. So let's talk about the origin of nuclear physics. How did it all start? The modern model of an atom is based on the planetary model. Just like we have the planets in orbit about the sun, the atom is likened to a planetary system with negatively charged electrons occupying discrete orbits about a small positively charged central mass of very high density called the nucleus, consisting of protons and neutrons. The protons and the neutrons are collectively called the nucleons. From our description, we can see that the modern atom has two main parts: the orbit, where the electrons are located, and the nucleus, where the protons and the neutrons are found. Nuclear physics is limited to the study of the nucleus alone. That is, the study of this small, positively charged central mass of very high density. And that's why it is called nuclear physics, the study of the nucleus. It all started in 1896 when Henry Becquerel observed that photographic plates were being forged by unknown radiation emanating from uranium ores, leading to the accidental discovery of radioactivity. It is now known that uranium is just one of many of such nuclei, which are now called unstable nuclei. Unstable nuclei decay, releasing energy in a process called radioactivity. To investigate the observations made by Becquerel, two sets of scientists. We have on one hand a husband and wife, Pierre and Marie Curie, and on the other hand, Rutherford and his collaborators, particularly Geiger and Marsden, investigated the discovery by Becquerel and found out that there are three distinct types of radiation that emanate from unstable nuclei. We have alpha rays, beta rays, and gamma rays. They were given these names because at the time of discovery, their exact nature wasn't known. But it is now an established fact that alpha rays are actually the nucleus of a helium atom. Beta rays are simply fast-moving electrons or positrons. And gamma rays are electromagnetic radiation of very high energy. Scientists ask themselves, how can a nucleus like uranium release energy without an external supply? This was definitely a remarkable discovery and opened the market for uranium. The commodity energy is very important to physicists because it is energy that makes things go or get work done. So this discovery pushed many scientists into research about this, in quotes, mysterious tiny mass, and the results have been amazing, thereby launching this sub-branch of physics known as nuclear physics.